In this lecture, we will continue to study quadratic models. The skills you will need to master the content of this lecture are: you must be able to sketch the graph of a quadratic function. You must be able to find the vertex of a parabola. You must be able to find the x-intercept of a parabola. Several of the models that we will be studying involve the profit function. In economics, labels are very specific. Economists use P to represent the price of an item, Q to represent the number of items. Please note that these two letters are lower cases. Capital C to represent the cost of producing items, capital R to represent the revenue generated from selling items, and pi. This is often used in mathematics to represent the number pi, but in economics, pi indicates the profit generated from producing and selling items. So this is a function we will see in several of our examples. Let's go over some examples now. Here is a first example from your note. An apartment building has 50 units. The rent per unit is a function of the number of units rented. The fewer the number of units rented, the higher the rent, which means if there's only one apartment rented in the whole complex, it's going to be a very expensive rent as opposed to 50 units rented. When the cost to maintain each unit is taken into consideration, the formula pi of n equals this gives the monthly profit in dollar when n units are empty. Okay, so this is when n units are empty, not when n units are rented. What is the meaning of the y-intercept of the equation? What is the number of units rented that will maximize the profit? What is the maximum profit? Okay, so first, y-intercept of the equation. Let's graph this equation quickly. Here's the y-axis, here's the x-axis. On the x-axis, I'm going to put n. N is the number of units that are empty. On the y-axis, I'm going to put pi of n. Pi of n is the profit. Now, the equation is a quadratic function concave down, and this is my y-intercept. So it's going to be something like this, okay? Now, the meaning of the y-intercept right here, this is 140,400. Well, this is when n is equal to 0, right? N equals 0 means no units are empty, no empty units, right? So if you rent all units, when all units are rented, right? Then you get a profit of $140,400. That's the meaning of the y-intercept. Now let's find the number of units that will maximize the profit, and let's find the maximum profit. For that, I need to figure out the vertex of the quadratic function. So let's take the quadratic function and let's figure out its vertex. We know what to do to find the vertex. We divide both sides by the leading coefficient, negative 150,000. The numbers should be nice because the numbers of units empty has to be an integer, right? So we have pi of n divided by negative 150 equals, so n squared. If you divide 2400 by negative 150, you will find negative 16n. And then if you divide 140,400 by 150, you will find 936. So now we can complete the square here. That's n minus 4 squared minus 16 minus 936. So it is n minus 4 squared minus 936, and 16 is 952. And finally, we're going to multiply both sides of this equation by negative 150 to get the vertex form. See, the numbers are very friendly here. Just need the calculator to do with these big numbers. And I have the profit is equal to negative 150 times n minus 4 squared plus, again, please use a calculator here, and you will find 142,800. Okay, so what is the maximum profit? So the maximum profit is $142,800. How many units must be left empty? 4 empty units. That's it. The vertex form answers the question. Let's go over the second example. So this problem is about a soft drink vendors at a beach. And after analyzing his sales records, he finds that if he sells Q cans of soda in 1 day, his profit, so that's a profit per day, would be given by this equation. What is the meaning of the y-intercept? And what is the maximum profit and how many cans of soda must be sold every day to maximize the profit? All right, let's answer the question. So first, let's find the meaning of the y-intercept. So pi of q equals negative 0.001 q squared plus 3q minus 1800. So the y-intercept is when q equals 0. So pi of 0 is negative 1800. Now remember, pi indicates the daily profit. 0 is the number of cans sold. So if the vendor doesn't sell any can, his profit is negative $1,800. What does it mean that the profit is negative? Well, the profit is the money that comes in from selling the cans minus the money that goes out from preparing the cans or maybe buying the can at a reduced price, right? So of course, if he doesn't sell the can, it's going to be at a loss. He's going to be losing $1,800. He probably bought the can from a bigger vendor and he hasn't sold any. So that's a loss right here. Okay, so now let's figure out what's the maximum daily profit and how many cans must he sell to maximize the profit. Before that, let's look at the graph of this equation. So this equation is a parabola that is concave down. It has a negative y-intercept. It's going to be like this. So we can see that the parabola will have a maximum. On the y-axis, you have the profit. On the x-axis, you have the number of cans that you sell every day. There will be a certain number of cans that will maximize your profit. Okay? So how do we find that number? Well, it's all about the vertex of the parabola. So let's find the vertex form of this equation. This time, I'm going to use the calculator for it. Instead of doing the algebra behind it, I'm going to use my calculator. So this is going to be my A, negative 0.001. B is 3. C is negative 1800 square. Let's take the calculator. So negative 0.001 stored in A, 3 stored in B, negative 1800 stored in C. Okay, now let's get the x-coordinate of the vertex, which is negative B divided by 2A, like so. This is 1500. So let me write it down. So H is 1500. So I can start writing my parabola in vertex form. I know A is going to be the same, negative 0.001. H is 1500. Oh, not X, but Q right here. This is Q. Q minus 1500. Now let's figure out the K. We know what to do to find K. We must use, do I have Y1? Yep, I still have Y1. So now I'm going to do Y1 at negative B over 2A. So Y1 is alpha trace Y1 of this quantity right here. So enter, close the parenthesis, and it is 450. So right here I have plus $450. So that's it. I have my answer. The maximum profit is $450. And to realize the maximum profit, right, I need to sell 1500 cans. So again, please make sure you write a sentence to express your answer. Let's go over the next example. This is an example I'm going to leave for you. So please read the problem carefully. Find the price that will maximize a profit and find the maximum profit. Again, this is a function. I've done it twice. It's the same idea. Let me move to example number 4. Okay, this example is a little bit different. We're given the profit, again, pi. We're given the profit that a company makes from selling a number of items, Q. But this time we know that Q must be above 0, but less than 500. So we have a constraint on Q. What is the meaning of the y-intercept? Now, please make sure you read and understand the next sentence. In economics, a break-even point describes how many products a company must sell to be profitable. What does that mean, to be profitable? It means to start making a profit and not lose money. How would you find the break-even point for the model? What is the maximum profit and what is the number of sales required to make this profit? Okay, I think the best way to answer the question about the y-intercept and the break-even point is to quickly sketch the graph of this parabola. So here we go. Here's the y-axis on which I'm gonna plot my profit, pi of Q, and on the x-axis I have the number of items sold. Now you can see that your y-intercept is negative right here, and then the parabola is concave down, so it's going to be this way, right? Okay, so what is the meaning of the y-intercept? Well, this is the profit, but what does it mean profit when it's negative? This is a profit you're making if you don't sell any item. So you're losing money, right? Because you need to come up with a product. Maybe you're making it, maybe you're buying it from a bigger seller, but you're losing money. You've invested money to sell something, but you're losing money because you haven't sold anything. So the y-intercept represents the loss from not selling any product, right? Any product. Because the y-intercept, of course, is for Q equals 0. So you're not selling anything. Now, the break-even point, when do you start making a profit? Well, just look at this graph, right? Right here, you're not making a profit. It's still negative. You're selling some product, but the profit is negative. Right here, you're selling some product, but the profit is negative. So you're not selling enough to compensate the cost involved, right? The cost that you have to pay to make or buy this product. But right here, this is when the profit is equal to 0. So above that point, you start making a positive profit. So this is the break-even point right here. That's a break-even point. How do you find it? You have to solve the equation pi of Q equals to 0. Okay, and then for the maximum profit and the sales required, well, that's easy. You find the vertex. So actually, I'm going to start with the vertex because I know to solve the equation pi equals 0, it's easier to start with the vertex. Okay, so let's get the vertex and then we'll solve the equation pi of Q equals 0. All right, so let's get the vertex form. Again, I'm pretty sure my numbers are going to be friendly because they must be integers. So I divide both sides by -8 and I have pi of Q divided by -8 equals, so Q squared minus 98Q plus 720. Okay, so let's complete the square. So this is Q minus 49 squared minus 2401 plus 720. So it is Q minus 49 squared minus 1681. And again, last thing to do is to multiply by -8 both sides. So I have pi of Q equals -8 times Q minus 49 squared plus 13,448. So I start by answering the last two questions. The maximum profit is $13,448. The number of items I must sell to get the maximum profit is 49. Now let's figure out the break-even point. For the break-even point, I must solve the equation. To find the break-even point, I must solve the equation pi equal to 0. We've already explained why, right? This is when you start making a profit. So let me take my vertex form right here and let's make it equal to 0. Negative 8 times q minus 49 squared plus 1348 equal to 0. So move that on the other side. Negative 8 times q minus 49 squared equals negative 1348. Let's divide by negative 8. Q minus 49 squared equals this. So this is 1681. So I'm going to finish in one step. We've done it 10,000 times. Q equals 49 plus or minus square root of 1681. Now the square root of 1681 is a very nice number. This is equal to 41. And so we have 49 plus or minus 41. So what is this? What is 49 plus or minus 41? Well, 49 plus 41 is 90. 49 minus 41 is 8. We have two positive numbers. It makes sense if you look at the graph, right? Both numbers right here are going to be positive. So this is q equals 8, and this is q equals 90. So in order to break even, in order to make a profit, the number of items you must sell must be above or equal to 8. And of course, you want to maximize the number of items at 49 right here, right? We said that before. If you sell above 90 items, you're going to be losing money. So you don't want to sell above 90 items, but in any case, the number you're looking at is 49. Okay, I hope this was clear. Let's go over the last example. Okay, this last example is a little bit different. Here we are given a rectangular flower bed, and we're told that its length is 8 yards less than twice the width. So let's draw the rectangle right here, right? And the length of the bed, let's call that the length and let's call that the width. And we know that the length L is 8 yards less than twice the width. So I need to take the width, I need to multiply by 2, and I need to subtract 8 to find the length, okay? The area of the bed is 570 square yards. I think yard is YD. Find the dimension of the flower bed. Okay, so again, this is a little bit different than what we've done. How do we find the dimension of the flower bed? Well, what's the area of a rectangle? The area of a rectangle is the length times the width, right? Here, we know that the area is 570. We know that the length, I'm going to take the length as 2w minus 8. So this is 2w minus 8 times the width. That's it. What is that? That's a quadratic equation in W. If you solve it, you will find the dimension of the flower bed. So let's solve it. To solve it, that's easy, right? You're going to distribute the W right here. So you get 2w squared minus 8w equals 570. So that's 2w squared minus 8w minus 570 equal to 0. Let's divide everything by 2. So we get w squared minus 4w minus 285 equal to 0. All right, I'm going to complete my square here. I think it's going to be quicker. So I have w minus 2 squared minus 4 minus 285 equal to 0. This is negative 289. So I have w minus 2 squared equals 289. And so we have w equals 2 plus or minus square root of 289. That is a very nice square root. It's 17. So it is 2 plus or minus 17. So 2 plus or minus 17 is equal to 2 plus 17, 19, or negative 15. Now, of course, W represents a width, and a width has to be positive, so negative 15 doesn't make sense. So we're left with W equals 19. So if W is 19, we get that L, which is, remember, 2W minus 8. So 2 times 19 minus 8 is 30. And so to answer the question, I will say that the dimension of the flower bed is 19 by 30 feet. That's the dimension of the flower bed. I hope everything was clear. Thank you for watching.